What this tool is about to do is going to blow your mind. And a lot of machinists are going to look at this feature in this part without watching this video and be like, how the hell did you do this?
This is a cautionary tale of what happens when you don't work with titans of CNC. Look at that perfectly symmetrical Picatinny rail. That's probably usable for something, I guess. Also, the difference in wall thickness side to side is kind of staggering. These cuts are there for a reason, and they're supposed to be in line with each other. They're not. This is potentially usable. I wonder why AK-50 takes so long sometimes? Shit like this. That.
Well, I guess you know what we got to do. Oh shoot, I still got a program. Well, as you just saw, the handguard that Brandon has for the AK-50 project is, well, let's just say it's not going to work. So we're going to help him out by making one here on our DVF 5000. Now, when it comes to handguards, this thing is huge. I mean, look how massive this piece of material is. And this handguard is a lot more complicated than your traditional handguards are, because normally you're buying these out of extrusions that already has a hole through it and you're just finishing the outside. But this one, we're going to make it out of a solid billet of 7075 aluminum, which is not as easy to get as 6061. And this handguard has a lot of thin walls, and just the sheer size of it means we're going to have a lot of long tools. We're going to have to really pay attention to our feeds and speeds, otherwise we might end up with a lot of chatter in this part. This is exactly what I was afraid was going to happen. Dude, you might as well cut, because this is not good. Quick disclaimer here, guys. I want to make it very clear that we are not making this part to throw shade at this other machine shop. If you have followed us for any amount of time, you will know that that's not what we stand for. We're about education and lifting this trade up. Now, that shop may have not had the right equipment to take on a project like this. They may have opted out, done it on several operations on a 3-axis, which is just not ideal for something like this. But we're going to do this part on a 5-axis, which is going to show you that having the right equipment will allow you to do complex parts like this much easier. All right, now back to the video. So the first operation here is just a material prep operation. We're going to deck the top and the sides. Go ahead and put a dovetail on it. Then I'm going to come in with a Kennametal Drill Fix Pro, and I'm going to do some chain drilling to get rid of the bulk of the material on the inside of the part. Now, we're using the Drill Fix Pro because of its centering capabilities. Most indexable drills doesn't have really good centering capabilities, but the way the insert's designed on the Drill Fix Pro, it allows it to center itself really well, making it good for chain drilling. Now, I've covered this topic in a previous video, but if you guys would like to see more on chain drilling, let me know in the comments and we can do a video just on that one subject. So after our drill runs, we're going to come in with a Core 5 and rough the outside. Now, this is just a basic roughing pass. We're just going to get rid of the excess stock that's going to be around the vise for Operation 2, so we don't have a lot sticking up for when we start tabbing the part. So after this tool runs, that's going to complete Op 1.
After that, we got to take this piece out along with the straight vise jaws and replace them with the serrated jaws. Then we can put the handguard back into the machine, holding it onto the dovetail.
Dude, what are you doing? You're the camera guy. Get out of my shot.
Yeah.
Anyway, yeah, what he said. We're going to start Op 2 now. Now we're going to start this out by using a 3/4 inch Core 5. Now, this is a 5xD tool. And when it starts roughing the inside, we won't be able to get all the way through, so we're going to come in from both sides and get as much as we can. Next, we're going to come in with a 3/4 inch duo lock that is sticking out 7.5 inches. Now, we've got to be very careful with this tool because it has a steel shank. So harmonics is going to be able to be built up in this tool very easily. And what that's going to do is it's going to start vibrating that tool, and it's just going to bounce off our material if we're not careful. Now, we're going to drop in and rough away that material that our Core 5 couldn't reach. So normally we always tell you to rough everything before you do any finishing work. And that's because something might end up moving. But in this case, we've got a lot of thin walls, so we're going to rough and finish the ID before we ever touch anything on the outside. This is exactly what I was afraid was going to happen. Dude, you might as well cut because this is not good. Oh, don't you just love it whenever your boss takes in a job and he's like, oh yeah, we're gonna make this thing perfect. We're gonna hit all the tolerances, send it to us, we got you. Knowing good and well the whole time they're gonna give it to you and it's gonna be your headache to deal with. That's kind of what I'm dealing with right here. But luckily I've got a machinist for a boss, so I'm about to enlist his help because what I'm dealing with here is typically you could run this tool at 15,000 RPMs, no problem. But the projection on this tool is so long that we're dealing with a lot of harmonics, a lot of chatter. As you can see, this thing looks awful. Now I called Barry over here and he said he didn't see nothing wrong with it. He thought it was just fine, but we both know that's his signature pattern. So of course he wouldn't see no problem with it. So I need to go get tight and see what he thinks about it.
Like, let it come into it. You just gotta get some bang. You should just take your handle inches and just let it bend.
Oh yeah, right off the bat, that's making a huge difference. I don't know, what do you think? Maybe we need to go a little bit lower? Oh yeah, I think that's it. That's sounding a lot better. Yeah, I think that's it. I think we take a little cutter comp out of it and try it again. All right, y'all can hear that now. That is sounding so much better. So Titan had to come in and remind me that there's a time to murder material and there's a time to kiss the baby. And in this case, I just wasn't kissing it loud enough. I was on the right track, but I hadn't got there yet. So I was down at around 3,000 RPMs and that was still way too high. So Titan come in, dropped it down to 900 RPMs. We're right at 4 inches a minute on our feed. That's lightened that tool pressure up even more and cut down on the harmonics that is being put into the tool. So now we've got a really good sounding tool and I think the finish is going to come out great now. Okay, now the ID is finished. We finally made it through that. It's looking really good, but we're not out of the woods yet. Now we have to rough the OD. Now this is where we're going to start revealing those thin walls. Everything's going to get super thin. So when we start finishing this outside, it still could chatter and ruin everything that we've done up until now. Now that the Core 5 has roughed the outside, now we're going to call up a 3/8 tool and start finishing everything. Now coming up, we've got a very difficult feature to machine that's going to have several challenges to it. Now this is where a CAM software can make or break you, especially when you're programming on a 5-axis machine. And I've got to hand it to Mastercam. I love the direction that they have taken their multi-axis modules in, because not only are they extremely intuitive, they give you several options for machining strategies. Now normally you don't have that luxury when something is that intuitive. So for these pockets and holes on the face, I'm going to come in with a small drill and drill those out just to get rid of the bulk of the material. Next, we're going to come in with our Picatinny form tool. Now we could do this with multiple tools, but it's just easier, and I know that the shape is going to be correct if I go ahead and use a form tool. So that makes it to where I just have to make one pass down each side and that whole Picatinny rail is complete. All right, next we're going to come in and finish our holes, rough our slots, and do the grooves that's on top of the Picatinny rail. Now for this, we're using a 3/16 end mill that is necked back 1 inch. I like to use neck tools whenever I can because it makes the tool so much more rigid. Now we don't need that whole length of cut, we just need the reach. So in order to keep it as rigid as possible, that's where neck tools really shine. All right, next we're going to rough and finish those pockets in that face. Now these are just weight reduction pockets. They're not really doing anything. Next, we're going to call up a 1/4" ball nose, and it's going to finish some of these angled walls and fillets that the 3/8 tool couldn't reach. The 1/4" ball nose can't reach everything because of the design of this, so we're going to come in with a 3/32 ball nose and finish those areas that the 1/4" couldn't reach. So now we're going to come in and finish these slots, which are designed for the M-LOK Accessories. And our tool is an 1/8" tool that's hanging out a little further than we wanted to, and that's because this one vertical slot is actually all the way through the part. So we had to stick this tool out a little bit far in order to be able to get that length that we needed for that. So we're going to have to slow things down just a bit to make sure that we don't get any chatter on these slots. What this tool is about to do is going to blow your mind, because the pocket that it's doing is otherwise impossible. And a lot of machinists are going to look at this feature in this part without watching this video and be like, how the hell did you do this? I'm going to turn on my transparent mode so we can actually see what's going on with this tool. On the back side of this part, on this angled wall, there's going to be 2 more slots, but these M-LOK accessories need a certain wall thickness. And because of the shape on the inside, we've got a big fillet coming into where that wall is. So we really need a flat in there to make sure that that wall thickness is correct. So to do that, they've added these pockets. Well, the problem is there's no way to do those pockets unless you do them with a key cutter. The problem with a key cutter is the pocket width is wider than what the head of the key cutter can actually reach, because you would have to go through that slot. So what I did is talk with Brandon and their team about, instead of making this a square shoulder pocket, why don't we add a radius all the way around? That will allow me to come in with this 1/8" ball nose, and as you can see, we're just coming in with vertical passes through this end, and utilizing our 5-axis machine, we're able to put this feature in the part that would otherwise be a real pain to figure out how to do. Now, another thing that's making this possible is I'm using a Haimer shrink fit extension. Now, I love using these shrink fit extensions because not only can they go into other shrink fit holders, but they offer you a very slim design that allows you to get into tight reach places like this, which you're always doing on a 5-axis machine. So as you can see, this holder is getting extremely close to the edge of this part, but we're able to stay away from that, and we're also able to reach deep inside the part. All right, next we're just going to take an 1/8" chamfer tool, and we're going to chamfer everything that it can reach on the outside of this part. Next, we're going to come in with a Lollipop tool, and that's going to chamfer the back side of our slots. Because if you've ever worked with me in the past, you'll know that I do not like to deburr anything. So this is going to make sure that when this part comes off the machine, everything has a chamfer, everything is deburred, and I'm not going to have to do any manual work to this part. So now that we have everything finished on the top side, now we can start roughing away this material that's on the back side of the part. Now, we've left that on here this whole time to make sure that we have rigidity in this part when we're finishing all of this stuff on the top. But we're not going to take it all the way what we should. We're going to leave some there to make it rigid for when we finish this angled wall. We want to kind of take this down in certain sections. That way we still have rigidity, but we get this entire back wall finished. So once we've rough and finished as much as we can on the back wall, we're going to come in and make a slot in the center to reveal our 2 tabs. And once we do that, the only thing that's left to do is to come in and actually make these tabs to the thickness that we need to break this thing off. And for that, I'm making it 30 thousandths thick. So after we do that, Op 2 is complete, and as you can see, we almost done this entire part all in one operation. Oh man, this thing is looking amazing. I'm not gonna lie, if Brandon ends up anodizing this, I'm probably gonna get my feelings hurt a little bit. So we were able to use the tabbing method that I used in my previous video in order to get pretty much 99% of this part complete. So the only thing we got left to do is we need to do these M-LOK slots here on this back wall and this angled wall. But as you can see, we got that 5-axis wiggle going. I mean, check this out. So we're only holding on with 30,000 thick tabs. That's all that's holding this part on. So what we're gonna do for this third operation is I'm gonna change these jaws out and I'm gonna hold on this wall right here. But we got some super thin walls here and I don't wanna crush my part. Now we need to make us a block that slip fits on the inside of this to keep the vise from crushing our part. Now I want that to be a good slip fit. I don't want it to press in, but I don't want it to be too loose because then the vise can start distorting our part. But this feature can get pretty tricky to get an accurate measurement with. So let me show you what we're going to use to measure this with. Is some simple gauge blocks. Now you can see here I've got a stack up of a 1 inch, a .250 and a 1/48. So the nominal dimension is 1.4. So we're going to stack these until we find what slip fits into this feature and then we'll know what size to make our crush block. So I'm going to try this one first. So this is 1.398. Get it started here. You see that slides right in and out. And I can kind of move it back and forth and I don't get any wobble with this. And just by how that feels, I know that a 149, which will be 1.399, is probably not going to go. So I think we're going to make our crush block 1.398. And I can measure this with some micrometers just to make sure exactly what this measures. So that's pretty good. Yep, so I'm at 1.398 and 2/10. So that's what I'm going to shoot for my crush block. So now we're going to check how this fits in our part. It's a good thing we run that lollipop cutter because then we'd have really trouble getting this to work because we'd have burrs all down inside of here. Just going to slide it just like that. As you can see, it sits right inside of there. There's really no play. I don't feel it wobbling back and forth, so that's good. It's a nice slip fit inside this board, so now when we clamp, we know we're not going to crush our part, or distort it anyway, so when we start machining on this side, it's not all oblong and distorted. So now we're going to get these jaws changed out on our vise, get this last operation done, get this part shipped. For op 3, all we got to do is simply come in and do some more slots and this one hole. So for that, we're going to follow the same exact process that we did on op 2, but this time I don't really know how much I'm going to chatter because everything is so thin, so I'm not going to get as aggressive with it. And this part is done. Making this handguard has been extremely fun, but it has been a little bit stressful because this part being so big with these thin walls and long tools, it hasn't been the easiest to get good finishes that we normally get, but overall I've had such a fun time making this part. Dude, check out these internal pockets here. Those come out so nice. I'm really glad I was able to put those in there because Brandon wasn't sure if we would be able to do it or not. And I'm really glad that we found a way to be able to put that in there. Now I gotta say, I'm extremely proud of this part. It came out so good. And normally, very long tools, thin wall parts do not mix. Now I gotta give some props to Brandon and his team on the design of this handguard. Now, even though it wasn't the most manufacturable, this thing is super cool and it's gonna look badass when this thing is all put together. All right, so now you can see that our Picatinny rail is symmetrical on both sides. And if we go ahead and check this wall thickness, I'm getting 128, 128. So that's right. Now the last is our slot going all the way through here. Now from my calibrated eyeball, that does look like they are straight across from each other. But that is the good thing about running this on a 5-axis. I did do it half and half, but since I did it in the same operation, I can pretty much guarantee that this slot is in line with each other. So at least that fixes the issues with the part that Brandon had. Now as for the rest of it, I really don't know if it's good or not. So for that, we're gonna have to send it over to Travis. Now again, guys, this is not to throw shade at that other shop and to say, hey, look at us, we're better than you. But this is a perfect example of what could happen to you if you put out this type of quality. Now, it's not a bad thing if you scrap a part internally, but a part like that should have never made it to the customer. If you do something like that and somebody else swoops in and says, hey, send me that part, I can make it perfect. And if they do that, you just lost a customer. So you have to have a good quality management system in order to keep things like this from happening. If you like this video, hit that thumbs up. And if you haven't already subscribed, then you may want to think about doing that now. And hit that join button where you can become a member on our YouTube channel and get access to our Discord server where you can talk to us and get a lot of other perks. Now don't go anywhere because at the end of this video, Barry's going to hand deliver this part to Brandon Herrera's team. So you don't want to miss that. Thank y'all for watching. We'll see you next time. All right, guys, I just got this out of quality. Travis says it is perfect. So I'm gonna go try to find a box so we can get this thing shipped today. Oh my God, oh God. Oh no, oh no, 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 no. Okay. Anyway.
Man, you know, it's kind of funny where machining might take a person. You know, one day I'm assembling parts at my grandfather's shop. Next thing you know, I'm on a beach in Hawaii FaceTiming Titan Gilroy. Now it's Saturday morning. I'm over here visiting with Brandon Herrera's guys, dropping off another AK-50 part. Wednesday, I got to run the Gas Monkey garage. You know, it's tough, but there's some things I'll volunteer for. What's up, Zach?
Hey, how's
it going, bro? Happy Saturday. Oh, man. So this was the original handguard that I saw Brandon talking about in the video. And, you know, the quality of this part looks like something that I would expect out of Jesse. You know, a lot of chatter, a lot of mismatches. So hopefully the one you got here today is better. Jesse still made this, and, you know, he's just a toxic mullet-having hillbilly. But he had me and Titan over his shoulder the whole time he was making this, telling him exactly what to do for every operation. So let's see if you like this one any better.
All right. I'm sure it's better than anything we could do.
Well, it should at least be better than what Jesse can normally do. Yeah, so
beautiful.
Picatinny rail is good. Your slots are both on the same plane, so.
Yeah, I saw the tabs you guys had going on the clip the other day.
Yep.
That was awesome.
Yeah, man, it came out really nice, but
it's cool to take such a crazy over-engineered design and actually manufacture it.
So, you know, as I was standing here, I had an idea, and, you know, I've seen a lot of Mr. Beast videos where, like, they'll have a car or something, and, you know, the last person to take their hand off of it gets to keep it. Mm-hmm. So I kind of feel like, you know, we ought to partner up and do a video like with this Barrett, say. You know, just stand around for a few hours until everyone else gets tired, and then I get to take this sucker home.
Well, I mean, you got to get paid for the handguard somehow. But,
that's,
you know,
true, that's true.
I could sleep here. We got AC here. I keep my hand on this all day.
You know what? Never mind. Oh, man, it's good to see you again. Thanks for the opportunity to help out, and we'll see you again soon, I'm sure.
Right on.
It's craftsmanship right there.